Hi everyone, welcome to Orgo Essentials, not your basic organic chemistry tutorial. In this special episode, I'll be reacting to my old organic chemistry paper. Let's get started. Before we look at the actual paper, here's a little background. This paper was the final for my Orgo class, the culmination of everything we had learned over the semester. We were given a list of compounds and instructed to write about whichever one we chose, relating it back to the concepts we had learned about in class. I chose to write about the molecule progesterone, and I had a lot of fun exploring all of progesterone's characteristics and properties. Now, without further ado, Progesterone and its Organic Chemistry, by me, Rachel Chubb. Progesterone is a chemical compound that half of the world's population is intimately familiar with. That's a good opening statement. Previously dubbed hormone of pregnancy, I missed a "the" there, progesterone is one of the main hormones responsible for fertility and menstruation. Every month, its concentration in the body rises and falls, triggering sophisticated biological and chemical processes. I did not know what I was talking about here. This is so vague. Though progesterone is mainly considered a female hormone, its organic chemistry is something that everyone, regardless of gender, can appreciate. Progesterone is a steroid hormone in the class of progestogens, with the chemical formula C21H30O2. As is characteristic of steroids, it is hydrophobic and consists of 4 fused cyclic hydrocarbons. Its functional groups include a ketone group, 2 methyl branches, those aren't functional groups, they don't do anything, and other oxygenated groups. Like all steroid sex hormones, its structure can be derived from the steroid cholesterol. Progesterone was first isolated from hamster ovaries by William Myron Allen and George Washington Corner of Rochester Medical School. Its common name was derived from progestational steroidal ketone. That's very clever. I bolded the parts that formed progesterone. Though its IUPAC name is actually pregforene 320-dione. That's a mouthful. Progesterone is a structural precursor for other sex hormones such as testosterone, estradiol, and estrone. I don't know what most of those are. Because of these purposes, it can be found in both males and females. Purpose in the female body. Though progesterone is always present in the female body, levels increase dramatically during the second half of the menstrual cycle. It's secreted by the corpus luteum, a temporary endocrine gland produced just after ovulation. This increased progesterone concentration prepares the uterus for possible implantation of an embryo by thickening the endometrium, the mucous lining of the uterus, and prohibiting certain muscle contractions of the uterine smooth muscle that would cause the body to reject an egg. This is actually really interesting. I like this part of biology. Obviously, I'm more of a chemist than a biologist, but I like this discussion of how the chemistry affects biology in such everyday actions. If no pregnancy occurs, progesterone levels will drop back down. This results in the breakdown of the corpus luteum, signaling the start of menstruation, as seen in Figure 1. During this phase, lowered levels of progesterone allow the endometrium to break down, eliminating any waste or toxic materials. If there is conception, on the other hand, then the body's progesterone concentration will not drop, instead staying relatively high throughout the pregnancy. In the very beginning of the pregnancy, progesterone decreases the immune system functionality, allowing the egg to be accepted. That's just incredible that the female body literally gets rid of its own defenses to allow the egg to be accepted. It's so mind-boggling. Once the placenta develops, it will also secrete progesterone. This increase in progesterone gives the body the ability to provide the blood vessels in the endometrium that will feed a fetus and prevents any more eggs from being released, ovulation. Progesterone even plays a role in the ending of a pregnancy. Some studies have shown that a drop in progesterone levels signals the beginning of labor. This decrease in progesterone concentration also triggers milk production. And here is lovely Figure 1. This is really interesting, but I don't really know what it has to do with organic chemistry. I think I was just ranting about what I thought was really cool. Progesterone has a purpose outside the reproductive system, too. The hormone normalizes cell oxygen levels. Without enough of it, cellular respiration may become dysfunctional, leading to cell death. That's really interesting, and not a lot of people know this, which is a shame because it literally keeps your body alive. Progesterone is also the reason behind fat stores in female secondary sex characteristics, such as cellulite. These stores provide valuable energy to women. That's an abrupt sentence. Finally, progesterone regulates the effects of its partner hormone, estrogen. It prevents the endometrial cancer that is so common in women with too high levels of estrogen. Clearly, progesterone is a very important hormone in women. Due to this, low levels of progesterone can lead to devastating effects. Women who don't have enough progesterone may struggle to conceive because progesterone isn't there to trigger the proper environment for an egg. In pregnancy, low levels of progesterone have been correlated with a higher risk of miscarriage or preterm delivery, harming both mothers and their offspring. Apart from pregnancy-related issues, a low concentration of progesterone may also cause abnormal menstrual cycles or dangerously high levels of estrogen. I think every woman, and really everyone, should know this. I mean, it has to do with pregnancy and normal menstrual cycles. It's so important, and nobody knows what progesterone does, except for if they have medical issues and need to be taught about it. Progestins and progesterone. That's a tongue twister. Progestins are synthetic steroid hormones with progesterone-like properties. They were first created in the development of birth control. I want to know more about that. I don't actually think I read the full story behind how progestins were developed, but it sounds kind of cool. Since progesterone doesn't absorb into the body very well in pill form, something else was needed to bind to progesterone receptors and create similar effects. I don't know why progesterone doesn't absorb into the body very well in pill form. That seems like something I should further find out. Now, progestins are often combined with estrogen in contraceptives such as birth control pills and skin patches. Because progestins can prevent the endometrium from building up, they can also be used to treat common menopausal symptoms, such as hot flashes and vaginal dryness. They are often used in combination with progesterone and estrogen to treat amenorrhea, an absence of menstruation, endometriosis, growth of the endometrial tissue outside of the uterus, and irregular menstrual cycles too. That's very cool, and I forgot all of this. Stereochemistry of progesterone. Finally, we're getting into the actual organic chemistry. I'm sorry I've been boring you with biology for all this time. Recently, the stereochemistry of progesterone has revealed a key clue in the mystery of the evolution of steroid hormones. When progesterone molecules and double-stranded DNA molecules were modeled using computers, a certain complementary was discovered. What was I saying? How did I get a good grade on this? The progesterone fit into partially unwound DNA like a lock and key. Van der Waals forces could be observed all over the resulting progesterone DNA complex, along with hydrogen bonds between progesterone's two carbonyl groups and DNA's phosphate groups, as seen in Figure 2. This virtually perfect fit was confirmed with energy calculations. Both the van der Waals forces and electrostatic forces of progesterone were lowered when progesterone was inserted into the unwound DNA, proving that the resulting complex is stable, because stable complexes are lower in energy, and that's what everything is ultimately trying to do in our universe, lower energy. The two molecules were described as having favorable steric interactions, with stereospecific hydrogen bonds. I was scared to take these words out of quotes or reword them because I didn't know what they meant. Put simply, the structure of progesterone was directly reflected in the stereochemistry of DNA. This implies the evolution of steroid hormones was closely connected to that of DNA. Information like this helps scientists to understand the reasoning behind the structure of progesterone and other steroid hormones. This is also valuable in the medical application of progesterone. Structure is linked to function, so the more that is understood about the structure of progesterone, the more that can be hypothesized about its functions. That's so vague, I didn't know what I was saying. Here's a note on figure 2. The first image is a model of the electrostatic forces and hydrogen bonds in a progesterone DNA complex. Matching colors signify functional groups that bond together. The second image is a model of the van der Waals forces in the complex. Notice how I didn't really explain the second image? It's because I didn't understand it. I don't know what the blobs are supposed to be. I don't know what the colors are supposed to be. I don't know how they got the image. I have no idea. Anyway, moving on. Progesterone and its enantiomer. Stereoisomers are compounds with the same atomic bonding and molecular formulas, but different arrangements in space. Enantiomers are a specific type of stereoisomers, in which two compounds are mirror images of each other, but can't be superimposed on top of each other. In short, they're chiral, a word derived from the Greek word meaning hand. Don't know why I included that. This is supposed to be an essay about organic chemistry, and here I am talking about Greek. Enantiomers can be easily spotted as they contain no mirror planes, no equal and opposite halves. In chemistry, enantiomers have mainly the same physical properties, such as melting point and solubility. This is because, since they have the same bonding, their intermolecular interactions are identical. Logically, this means that progesterone and its enantiomer, creatively named end-progesterone, have similar properties. Look at me dissing IUPAC for how they name enantiomers. Oh my gosh. In medicine and health research, this proves very valuable. For many years now, traumatic brain injury has been one of the leading causes of injury and death in young adults. Unfortunately, not many treatments are, quote, effective in reducing mortality or limiting disability from these injuries. However, current research shows that progesterone has a promising potential to change this. I sound like I'm reading a news article. This is ridiculous. When scientists were studying the demographics of brain injury recovery, they found that biological females tend to recover faster and more completely than males from brain injury. Despite this, women tend to be diagnosed with more brain decline-related diseases, such as Alzheimer's in old age, than men. These seemingly contradictory patterns can be explained by the fact that progesterone contains neuroprotective qualities. Older women, in their postmenopausal years, have lower concentrations of progesterone, so their brain cells aren't as protected from function decline as those of older men are. I don't know what older men have protecting their brains, but okay, so not fair. Younger women, on the other hand, recover faster from brain injury than young men, because their brain cells are more protected by higher levels of progesterone. As it turns out, progesterone isn't just produced by the reproductive system. It's also present in large quantities in the brain. It's been studied as a neuroprotective agent in 5 species, including humans, with 22 different neurological injuries. In every single cell, animal, and human model, it protects nerve cells against damage and impaired function. I don't know how it does that, and I really want to understand the mechanisms behind that, because that's ridiculously cool, and think of the implications that this could have. Specifically, progesterone has been correlated with reduced neuronal loss, less damage following a brain injury, and less cerebral swelling. It does this by influencing over 500 genes, acting on proteins, and sending messages to hormone receptors. In the cells, for example, it stabilizes mitochondria, leading to less apoptosis, programmed cell death. I want to understand how it does this. Oh my gosh, this has so many implications, and it could be so beneficial to not just women with progesterone already in their bodies, but like everyone. What does this have to do with enantiomers? Good question. I think I tend to go on tangents when I write, and this has been a very long tangent. As mentioned before, progesterone and its enantiomer have similar properties, and this holds true for neuroprotective properties too. Just like progesterone, end-progesterone reduces rates of cerebral swelling, cell death, and inflammation. Though much chemical research remains to be done on end-progesterone, just this similarity illustrates the power of enantiomers and stereochemistry in health. And here's figure 3, atomic model and chair conformations of progesterone and its enantiomer, and progesterone. I think I liked this figure and I included it, even though it's kind of unnecessary, because we had just learned about chair conformations in class, and so I wanted to show off to my teacher that I had indeed listened to her. Conclusions. Not just one conclusion, no, multiple conclusions I had. So fancy. Though progesterone is undoubtedly one of the most important hormones in the female body, much research remains to be done in how it can be used to help women. For instance, does using progesterone to treat menstrual disorders lead to side effects in the brain? Is there such thing as too much progesterone in the body? Trick question. There's such thing as too much of everything. That's why our body maintains such balance. Don't know what I was saying. I think I was just building up word count. How is progesterone used in animals that don't menstruate, i.e. most of the animal kingdom? That's right, most animals don't menstruate, and it's really unfair that we do. I don't get it evolutionarily. I really don't. Why can't all women simply turn to progesterone or progestin pills for painful menstruation? Similarly, there is much to be learned about progesterone. Why doesn't it occur naturally if it has such healing properties? Could it be used as an alternative to progesterone in medicines and contraceptives? How did progesterone evolve out of DNA and not progesterone? I'm sure you could find the answers to these questions. I'm sure people have found them. I just wasn't reading those papers, I guess. Finally, there remains much work to be done in educating people about progesterone and its significance. Finally, I'm talking sense. Oh gosh. General audiences, not just chemists and biologists, need to understand that progesterone isn't just a woman's thing. So true. It's present in every human body on the planet. Though progesterone does play an important role in the female reproductive system, it clearly offers, typo here, that I somehow got a good grade on, healing qualities that everyone should care about and be aware of. Half of the world's population is already intimately familiar with progesterone. It's high time everyone knew about it. Tying into the beginning sentence. Wow, that's clever of me. And that's it for my paper in this video. If you have any questions about my paper or the concepts I discussed in it, feel free to email me or comment down below. I'll see you later.